Hello, this is Ross Kenyon of Nori. I am a lead strategist there. I have with me today Christophe Jaspe, who's Chief Development Officer at Nori. Nori is a carbon removal marketplace. We care a lot about direct air capture, and yet on our other podcast, Reversing Climate Change, we have not spoken about it nearly as much as we should. And that's at least partially due to the fact that we are launching our first methodology is with soil carbon and regenerative agriculture. So opportunistically, most of the people that we speak with and have on the podcast are in that space. But we love direct air capture. We think it's super interesting. Christophe's background is actually in direct air capture and working with Klaus Lackner. So Christophe, why don't you give the carbon removal listeners an intro to direct air capture and tell them about this article that came out today in the New York Times.
Thank you, Ross, and it's great to be on here on the Carbon Removal Newsroom with you. The article we're going to talk about today that came out in the Sunday edition of the New York Times is entitled, "This Tiny Swiss Company Thinks That It Can Help the World Stop Climate Change." The company in question is Climeworks. I actually had the pleasure of visiting their plant opening back in 2017.
Oh, yeah, you showed me that video. It's very cool.
Yeah, it was a historic day because it was the first day that people turned on a machine that's directly sucking CO2 out of the atmosphere. And that's essentially what direct air capture is.
Great. And then what exactly, I know there are many companies that are working on this. What is unique about Climeworks?
What I think is unique about Climeworks is that they have taken an approach that is looking for some of the niche applications for carbon dioxide where they can gain a market foothold where people are willing to pay a premium. The plant opening was in Hinwil, Switzerland, and it was at an area that met a number of criteria that support having an early adopter. First of all, Climeworks needs heat in order to make their process work, and so they were able to co-locate the direct air capture unit on the top of a waste incineration plant. Secondly, they were looking for a market that wanted that CO2 and was willing to pay more for it, and that waste incineration plant was right next to a greenhouse, and so they were able to actually feed the carbon dioxide to the greenhouse, which the plants need to basically enhance the growth and accelerate photosynthesis.
When we've spoken about direct air capture on our other show, Reversing Climate Change, it's oftentimes been in the context of permanent storage rather than something like this where it's going to greenhouses, which means it may not permanently be stored. And same with beverage carbonation, right? You drink the water, the gas comes out of the can, etc. So this is like the first step.
Correct. And it's an important distinction between carbon removal, where you're taking carbon which has previously been mobilized to the atmosphere and immobilizing it, versus direct air capture, where you're just taking carbon dioxide out of the atmosphere, upgrading it into a stream, which could be removed permanently, or it could just be used.
This is maybe the difference between like carbon capture and use CCU?
Not quite. So carbon capture and use is similar in the sense that it's finding a use for the carbon dioxide, but it really matters to trace the carbon molecule, whether this is something that was in the atmosphere or from a fossil. So CCU more often refers to fossil-based carbon.
Okay. And what else is in this article? What are they talking about in there?
The article talks about costs, and I think it's really important to discuss costs when thinking about direct air capture. Obviously, costs can be determined in a number of ways. One is, what's the cost to capture the carbon dioxide and get it up to a concentrated point where you can use it for merchant grade CO2? Another way is to say, what's the end-to-end cost to take CO2 out of the atmosphere and then convert it for use in some final product? When thinking about costs, the assumptions are key, as are how do costs come down when modular technologies such as direct air capture can take advantage of economies of scale. The ranges in the article go from around $94, which is cited by Carbon Engineering, another startup that's pursuing a slightly different way of direct air capture, all the way up to $400 a ton, which are the real numbers that Climeworks is facing today. The costs, quite frankly, are really hard to get right because we're still talking about pilot plants and not yet commercial scale demonstrations. And so it's still in the murky territory of assumptions. That gets even harder when you're also looking at a device that you expect to run for a number of decades and you don't know which parts you might need to replace, whether that's the sorbent material, which is doing the capturing, or some other mechanical part.
Okay, great. Yeah, that is the thing that people always seize on with direct air capture, given that it has that science fiction flair to it relative to other methods of carbon capture, such as ones that are ecological, like soil and changing farming practices, et cetera. People always want to talk about how much it costs and how fast that cost is coming down. So it sounds like it's still coming down quite quickly, maybe faster than people would predict. And I think, I don't know, maybe the next couple of years we'll see it even much more cheap.
I think that there's a lot of room for growth. There are plenty of opportunities. It's really important to understand the nuances. So I mentioned that Climeworks had co-located at a waste incineration plant because their process to extract CO2 needs heat. They're also looking for other opportunities with geothermal energy to both provide a carbon neutral source of energy as well as the heat to drive the process. I think that the idea that here is a technology that can theoretically scale limitlessly and is pretty much just plug and play and can capture CO2 anywhere is still a little bit fanciful, because for this technology, if it's to truly scale and come down on the costs that the proponents would like to see them come down at, then it's going to need to find those footholds where it can take advantage of other free sources of energy, such as heat and favorable locations.
Well, we're very happy to see this in the news. Congratulations to Climeworks and your publicist or whoever got that article placed, because it is a very nice one. And we'll keep updating on this story on direct air capture. We know people want to hear more about it, and we'll be sure to cover it. So thank you, Christophe, for being on Carbon Removal Newsroom.
Thank you.